Hello, welcome. Today let's try to solve another Leetcode problem, 2050, parallel causes 3. So for this problem, it's similar to cost scheduling. So let's just read the problem. So we have a prerequisite cost and we have the next cost. We need to finish cost 1 and cost 2 and then we can finish cost 3. But there's no time limit. For example, we need to finish course 1 in 3 months and finish course 2 in 2 months. So it means in 3 months we can finish course 1 and course 2, and then in 5 months we can finish course 3. So in total it's going to be 8. And I'm going to focus on this example to explain the problem, the second example, because I think it's more complicated than the first one. So in order to finish the course 5, we need to finish the previous course. So in order to finish this course 5, we need to finish course 1, 2, and course 4 and 3. But how should we do that? In order to finish course 1, we spend 1 month. And then we're gonna check what is the maximum time to finish course 2. I mentioned there's no course 2, 3, and 4 because I'm gonna use the topological sort with BFS. So currently we will ignore course 2, 3, and 4. If we need to finish course 1, we need 1 month. And then after finish course 1, how many months we need to finish course 5? We still need 5 months, right? So we're gonna prepare the maximum of this course 1 month plus this 5 months, because for BFS after topological sort, after pop out this 1 month, we're gonna have this 5 months because we can see it because 5 is the neighbor of 1. So we can take the maximum of cos 5. Currently it is the 6 because it is a neighbor, and 5 plus 1, it is 6 months. Now we're gonna check this cos 2. After we take the cos 2, we're gonna check its neighbors. Its neighbor is still 5. So we're gonna check the maximum. Previously, the maximum is 6. Now, 6 with 2 plus 5, so it is 7 months. Now, the maximum will be 7. Now we're gonna check this one, cos 3. After pop out cos 3, its neighbor is 5 or 4. Let's check 5 first. So its neighbor is 5. So 3 plus 5 is 8. 8 is more than 7 before. So currently the maximum of cos 5 is 8. But it's not finished yet because after we pop out this 3, we have a neighbor of 5, and then we have a neighbor of 4. So this 4 will be inside the queue. We need to pop out the 4 in order to check this 5. So if we were to pop out the 4, what's the result? It would be 3 plus 4. So currently at this position at time 4, because this time is also the same as the node. But later on I'm gonna use 0 to n minus 1 as the node because I think that would be simpler than from 1 to n. So currently while it goes to 4, so how much months I need? It is 7 months. Now I need to pop out this 4. While pop out 4, I need to find its neighbors. So its neighbor is 5. So what is the maximum at this position 5? So it would be 7 plus 5. It would be 12. 12 is more than 8. So this 12 will be the final result. As you can see, it's a typical topological sort problem and it's not so difficult. Now let me just start coding. So for topological sort, as I always prepared a graph and integrate. So the graph will be a adjacency list. So I'm gonna prepare a default dict list, and integrate will be just an array 0 times n. Now I'm going to prepare the graph and integrate. So for UV in relations. So for the graph GU, so here I'm gonna prepare U minus 1 because for all the node I'm gonna prepare from 0 to n minus 1. So I'm gonna append V minus 1. And for the in degrees, similarly, here I'm gonna prepare v minus 1, so the plus equal to 1. Now I prepared the graph and in degree, and then I need to prepare a DQ. So for the DQ, let me prepare a queue as a double-added queue. And inside, I'm gonna prepare the node. So for I in degree, for ID degree, for ID in enumerate the in degree. I need to check if this degree is 0. Yeah, I need to put all the 0 degrees inside the queue. So for this example, I'm gonna put node 1, 2, 3, but I've already turned 1, 2, 3 to 0, 1, and 2 inside the queue. I also needed to prepare a DP array. I'm gonna prepare a time. Yeah, because this time is like a record. It is a record for the maximum time needed when I finish this course. For example, time is 0 means this is not 0. What is the maximum time? It is 1. And for this 5, what is the maximum? Finally, this 5, the maximum is 12. 3 plus 4 plus 5. Yeah, so this is a DP array for the time. So time should times n, and now I need to check. Yeah, so for not in Q, because from the beginning, if this in degree is 0, I need to put a time, because I've already know the maximum time would be like 1, 2, and 3. Yeah, so T node should equal to time node. Now I'm going to use the BFS, so result should be equal to 0, and finally I'm going to return this result. So I'm going to check this queue. So the node would be q dot pop left, and I'm going to check the result. So the result would be the maximum of result with the time with this node. Yeah, let me give you an example for this one. Yeah, so currently this node is equal to node 1. Yeah, but actually it is node 0. And I'm gonna check the result 0 with t0, so it is 3 months. Yeah. Now, if I need to check next one, so the result would be the maximum of 2 with 3. So the result, I'm sorry. So for this node 2, so the result would be 2. Yeah, for this node 1, it would be 3. Yeah. Now I'm going to check its neighbors. So for neighbor in the node, I'm gonna update the DP array T. So T neighbor, so its neighbor is 3. So for this example, its neighbor is 5. So for T neighbor would be the maximum of T neighbor. Yeah, because currently this T neighbor is 6. While I'm comparing for the next one, 2 plus 5, it is 7. So I'm gonna prepare a T neighbor with let me check with T node. So T node is coming from this node 1, and I need to plus the time, so the time should be the neighbor. So for example, for the first example, so this node 1 and node 5, so currently T neighbor is 0. Yeah, because currently I don't have any value, T neighbor is 0. This T node is just 1 month, and the T time is 5 months. So 1 plus 5, it is 6. 6 with 0, it is 6. And next, it's going to be 7 and 12, finally. Now I can check for in degree. Yeah, so for neighbor inside the graph, T neighbor, I can update the in degree. In degree neighbor would be -1, and I can check the in degree. So this is basically the template for the BFS for topological sort. So if in degree with neighbor equal to 0, so q dot append with this neighbor. Yeah, as you can see, this is the entire code. It is not so many lines of code. Basically, it is just a template. Yeah, as you can see. Now let me just run it to check if it works. Yeah, as you can see, it works. Yeah, this problem is a little bit harder than the normal topological sort because yeah, we're gonna use the dynamic programming here. So this array T is actually the DP array. It is a dynamic programming because we stored the maximum time at each node. Yeah. Why we can do that? Because according to the topological sort, we can always find the maximum time at each node because topological sort is just take off the integrate which is equal to 0, we take off 1, 2, 3, and then we take off 4, and we take off 5, and finally we got the final result. Yeah, now let me submit it to check if it works. Yeah, as you can see, it works and it's pretty fast. And the time complexity is OE plus V. E is the number of edges, V is the number of vertices. Yeah, because the BFS for this topological sort, basically we just go through an adjacency list. And for the adjacency list, we're gonna check how many nodes, it is V, and how many edges, it is E. So the E and V is 5 times 10 to the power of 4. That is why it is so fast. Thank you for watching. See you next time.